Okay, so now we will discuss about the boundary conditions in electrostatic fields, and there is also magnetic field existing there. So in the general case, we can see that the normal component of electric field is not continuous because that d2 n cap minus d1 n cap equals to sigma, and the t2 is nothing but epsilon of e, and that difference is the surface charge density, as we can see. This happens because if you imagine that at the surface the electric field lines are perpendicular, so of course the normal component is going to be the perpendicular component, and that will depend on the charges present in the surface. And in case of the tangential component, which is referred as e2 dot t2 minus e1 dot t1, that tau means that the tangential unit vector. So in this tangential unit vector, we see that the difference is zero. That means that the tangential part of that surface, there is going to be no change in electric field. Even if there is charge present, there will be no change in electric field. And the second point, which is b2 n cap minus b1 n cap equal to 0, that means the difference between the normal component is 0. That is, the normal component of the magnetic field is consistent. There is no change in there. Okay, so what we and the tangential component, that is n cap cross h, that's equals to k, that is the current surface current density. So we can see that the tangential component of the magnetic field is inconsistent, and that we have to think about which terms are inconsistent. So at first the tangential component of the magnetic field is inconsistent, and the normal component of the electric field is inconsistent. In other words, you can say also that the tangential component of electric field is inconsistent and the normal component of magnetic field is inconsistent. And here we go to some special cases. If it is the dielectric media, then we know that there is no free charge existing in the surface of dielectrics. So in that case, the normal component of electric field will be conserved, I mean constant, because there is no surface charge there. But in this case, there was a surface charge sigma. For that, the equation 1 is different than in case of this case, dielectric media. And the normal component of magnetic field is constant, and it was also constant there, the normal component of magnetic field. And the tangential component of magnetic field is also constant, which was not the case in the previous case. We saw that there was k, a vector surface charge, there was surface charge, but in dielectric there is no surface charge because it cannot conduct current electricity. So in dielectric media, the tangential component of magnetic field is also constant, and the electric field tangential component is also constant. That was already constant in previous case. So we see that in dielectric media, everything is conserved. There is no change because there is no surface charge or no surface current. If there was any surface current, just note down my sentence. Okay, if there was any surface current, then the normal component of electric field will be inconsistent, and if there is any normal current, then uh, the magnetic field's tangential component and the normal component of the electric field will be inconsistent. And here comes the most critical case, that is conductor dielectric interface. Here the electric field E1 equals to 0, that is H1 equals to 0, because in conductor dielectric we can see that there is no electric field, because it is like it is going from dielectric from a conductor, so no electric field inside a conductor. So there is no electric field inside a conductor, so the tangential component of the electric field 0, and electric field is basically 0, so the whole component of electric field is 0. Magnetic field is also 0. And for the second equation we see that epsilon 2 e 2n equal to sigma. There is a dielectric field, or the d normal component of d field is sigma, and the tangential component of b field is the current electricity, because the first one is 0, the first one in both the cases, because in conductor there is no electric field. So as there is no electric field in conductor, so E1 refers to conductor, 1 refers to conductor, and 2 refers to the dielectric. So in the conductor the first one is 0, so it is just this case. Just imagine this case. If in this case, if you count that the E1 is 0 in the first equation, D1 is 0 because it is in conductor, just then the d2 n cap equals to sigma, that is referring to d2 equals to epsilon e, the epsilon 2 e n cap equals to sigma. That is the normal component of electric field also. And in the second case, if you think that n cap cross h2 n cap cross h1, then the h1 will be 0, so let's just select the mu1 by mu2 n cross b, that is the tangential component of magnetic field will be like the current density. So that was the overall thing. You can screenshot it if you want. Yeah, we are done here. I hope it was helpful. Even if it was not, you just try to understand it by your own.